Okay, welcome to IC Education, the only education that matters. Okay, we are doing 11. Do you have the soft copy, my brother?
Yeah.
Yeah, send it on WhatsApp. And I just want to open it here so that I can read. You can
Okay,
see
no
the
problem.
problem that we are solving.
Okay, give me a few seconds, ne?
Let's push, guys. Let's push. Where am I? Where am I? Did you send it?
It's loading, ne? It's loading.
Okay, nevertheless, let's continue. As it comes, we'll see it. Like I was saying, this topic is all about formula. In this case, because it is a centrifugal compressor, what do you need to know? You need to know the power. What is the power on the centrifugal? Power, they said it's equal to flow rate multiplied by, I think it just arrived. I think it just arrived. This book is heavy. I have to delete it after here. This thing is too thick. Let me make it, reduce it here. Yeah, this is the perfect size. Okay, what you need to know is the power. You need to know what is CBI. You need to know what is CBE. I'll try to make this class very short because I have an appointment in the next hour and a half. So, oh, Daphne Masimeme Bukalo. Hello, Bukalo.
Hi.
I didn't see you today. What happened?
So,
It was too
I was
cold.
not feeling good.
Oh.
Yeah.
Tomorrow is gonna be cold then.
Hi.
Yeah, it's loading. Okay, Bukalo, we are doing 11.20 and then 11.4. So I will try to do it as fast as I can, but in the understanding way, of course.
Okay.
So what you need to, if you open, where is this textbook again? Okay, on the soft copy, my brother, what's the page again? It's chapter 15, chapter 11.
Oh, I can't remember.
You can remember.
My dear.
What is chapter 11? It's chapter 2, so it's still. Even though I cry, it doesn't mean that I'm weakening. Where is it? This is chapter 5, ne? Chapter 6. Why is this thing not rolling like this? Yeah, it has to roll. My heart is beating do. I just wanna love you. I do. Hey, I love singing, you see. That's all I do when I sit alone. I sing. I just sing for a living. That's what I do. Okay, dynamic chapter. As you can see, for each and every type of blade, I think in strength 2 or is it 3, you guys did this part of the blade. This one, the impulse steam turbine. So where we are focusing now, where is it? It is 11. But this chapter is big, eh? It's huge. It's very huge, my guys. Where am I? It is a long chapter. You even have isentropic. What going there? Okay, we are on centrifugal compressor. So what do we need to know? All we need to know under this topic, my good people, is what's happening here, the speed that is happening here. This is CBE. When we talk this, okay, the good thing is this thing is always gradually. When you have how can I say it? You see on the problem what I mean. This is CWI. This is CAI, velocity at inlet. This is CBI. You just need to know this, but you see it's not that bad. It is not that bad, believe me. Let's go to that problem and do it. I don't wanna say much. Key 11.20. Let me print it. I just wanna love you, I do. I just wanna kiss you, I do. Hello, Bukalo. Guys, I'm gonna miss you because you guys gonna be the last generation that higher education has taught. Last, imagine.
You're not teaching next semester.
I am. You guys gonna be the last generation because this is my last one, my last year, my everything. I'm giving my all. Okay, guys, they said a centrifugal. Why am I shouting? I'm alone here. Why am I shouting? A centrifugal compressor running at speed. At speed, this takes air at 70 degrees and compressed through the pressure ratio. This is the pressure ratio, RP, of efficiency 82. They say the blades are inclined and the slip factor is 0.85. Guide the vent at the inlet. Guide the vent at inlet give. What am I reading? Guide vents at inlet give an air angle pre-wheel of 20. Okay, this one is pre-wheel. That's why we talk about W. Okay, when you hear about pre-wheel, that's why you talk about WR. You will see to the axial direction takes the mean radius of the impeller. I is to be this. Calculate the tip diameter at inlet. Okay, remember guys, you have two diameter here. You have the main radius, the mean diameter of the impeller eye. This diameter is the one that we use to solve the speed that the compressor enters. This tip, who's texting at this time? The tip, the impeller tip diameter is also something. Okay, nonetheless, before we start this topic here, remember they are talking to you about isentropic and pressure ratio. If you remember from chapter 10, when you have isentropic, there is this formula that says that. Let's start by that. There is this formula that says that efficiency is equal to, let me write, should I write it up or down? Is T2S minus T1. T1 is the temperature at the entrance, which is this one, 17. To be equal to T2 minus T1. That is what gives you the efficiency N, which is 0, this one. You also have this relation here that say that T2S over T1 is equal to, normally we write, I think we write P2 over P1. But P2 over P1 is what makes the pressure ratio RP. So that's one of the reasons here. We write it like this. We write it as RP, everything to the power, gamma minus 1. Remember, this is property of air, which is 1,4 over gamma. So when you have this information, do you know why are we given this information, guys? The only reason why you are given this information is to solve for the power. You have two ways of solving the power. The first way, according to the centrifugal compressor, you do have this formula. Let me show you. Where's the book again? Book. Here is the formula of the power input. Do you guys see it? Okay, you have the formula of the power input. Let me write it. What is the formula of the power? Let me copy from my textbook. Power, they say it is flow rate. If there's no flow rate, you don't write it. But there's flow rate of CBE. The only reason why there's flow rate, if you remember in class, I said everything that is flowing. Remember, on this centrifugal turbine here or what here, there is a liquid flowing. That's the reason why you see the presence of. Okay, my good guys, this is the power. You can also get power with these temperatures. What is power? Power is Cp multiplied by change of temperature. But in this case, what is the change of temperature? It is T2 minus T1. So, this type of question, I want you guys to see it like this. First thing you need to do when you have this problem, sometimes they can ask you to solve for this thing, the slip factor, or what? This information of temperatures given to you, this temperature here, this temperature here, and the efficiency here, it is given to us for us to solve for the power. So you have already an extra information. You see it now, CC. So that's the reason when you solve this power here, you can equate it here. So okay. Let's start with solving the problem. Let's solve the power. We don't have this one, we don't have this one, we don't have this one, but we can get the power here. Do we agree, guys?
Okay.
Bukhar, why are you saying great? Okay. Okay, Bukalo, what do we need to do quickly here if we have to solve for the power here? What do we need? We need T2 minus T1, right? Okay, we have T1. Do we have T2 minus T1 here?
We have T1.
T1 is the temperature at air here. 17. We have the efficiency, which is He2. Now, what can we do here, guys? We can do a quick math. Do you agree that if I can get T2S, I can solve for T2 minus T1?
Yeah.
No, let's start here. If we have to get T2S, what is T2S? T2S is what? Is T1 multiplied by RP gamma minus 1 over gamma. Can we do the calculation? What is T1? T1 is 17. It has to be in Kelvin. Are we all good? Multiplied by RP. RP is the pressure ratio, which is given here as 4. So you go 4, multiply by 4. What is on top? It is gamma minus 1. Gamma minus 1 is 1,4 minus 1 over 1,4. If you do this calculation, you get T2S. What is the answer? Hey, my G, you joined earlier. Are you with me?
It's 430,94.
No need to come here, eh, guys. You can understand. 430,94 Kelvin. Okay, do you guys agree that if I do have T2S, I can now solve for this guy here? I can use this formula here. I can make T2 minus T1 subject of the formula. I don't have to solve for T2. I don't know if you notice. Do you see? I don't have to solve for T2. I can simply make T2 minus T1 subject of the formula. What's going to happen? I'll have T2S minus T1 over what? Over N. So therefore, you have T2 minus T1 to be equal to what? What is T2S? It's what we just solved. 430.94 minus what is T1? 70 plus 273 is how much?
70 times
70 plus 273 to get this in Kelvin. It is 290, eh?
It's 343.
Is it 343? 17 plus 270.
Oh, you're saying 7. I thought you were saying 70.
No, forgive my English. What is N? N is 82%. So if you convert it, you have 0.2. 0.82. Hey, my G, I'm hungry. Maybe I can walk to town and get something to eat after here. Yes, what's the answer?
450. One 171,88.
171,88K. Okay, we need the power. I don't know, I see in your solution some are writing power W. It depends on what the lecturer wrote there, but me, I'm just writing P because I know it's power. We know that power is equal to Cp multiplied by that change of temperature. So what is Cp? Because it is air, this constant is 0.05 multiply. What is the change of temperature? Change of temperature is T2 minus T1. You can simply copy this value here, 1,71,88. So what is the power?
One comma 0.04 times 1. 172,74.
It is 172,74. Okay, Bukalo. Okay, after finding the power, what is the question? The question wants us to solve for this diameter here. Okay, this is where the thing starts. We need the power so that we can use it here and play around. When we use this formula here, we are saying that a centrifugal compressor handling at this speed takes air in this and compress with the ratio. The blade is gradually, the slip factor is this. Now, what are they saying? They say guide vines of air angle of pre-wheel is 20 degrees. I don't know if I can show you here from the drawing what it means. You have CAI, the inlet speed here. You have CAW. The CAWI here is what they are calling is it pre-wheel? What is it again? We're calling it pre-wheel. I don't know the English. To the axial direction. Now they say take the mean diameter of the impeller eye as 200 millimeter. So we do have the mean diameter here. Now what are we looking for, guys? We are looking for CBI, and then we are looking for this thing for CBE as well. Why are we looking for it, guys? We are simply looking for these guys so that we can substitute them in this formula here, in the main formula of power. From this formula now, we can solve whatever we want to. That's how it works. Now, how do you get CBI? CBI is the velocity at this centrifugal, which is this one here. CBI, if you have CBI, it is simply, what is the formula of CBI? Pi d diameter n over 60. This thing is rotating at this speed. Now, what diameter are we going to use here?
Sir,
Ask me a question. Ask me how.
I was saying, like, can you start by writing the data first?
Oh, I should start by writing the data, ne? Okay.
Yeah.
No problem. Where can I write it?
You can just wipe the
This
W, the P, yeah.
Okay, let's write the data. What are we given? We are given the revolution here, the speed revolution rev per minute here of the centrifugal force, which is, that's what will give us CBI. CBI will depend on that thing, which is pi d n over 60. Okay, we are fine then. We are given efficiency. The efficiency it is used to solve the power. Should I call it as well, that one?
Efficiency?
You see this efficiency here? Remember, the part that they gave you, the pressure ratio and efficiency, it is simply for you to get the power using temperatures.
Okay.
So I don't know if I should also...
Just right.
My dear. We are given the efficiency. The efficiency will be used. Let me just write the form that will be used. It will be used to find T2S minus T1 over T2 minus T1. Everything to be equal to what? Efficiency. Are we good on this one? You also have another information that we'll be using here. Hey, my dear, you want to make sure, ne?
This pressure ratio of 4, it's just like T1 over T2.
No. Normally the formula is written like this: T2S over T1 to be equal to P2 over P1. This one is the pressure ratio, but they already given to you as the pressure ratio. That's what make RP. If you check on chapter 10, that's how it's written. Are we good, guys?
So the 4 is P2 over P1.
Yeah, yes, that 4. It is called RP, pressure ratio. Whenever you hear pressure ratio, like for instance here, even on the example here, the pressure ratio was what here on the example? They said pressure ratio is 4 over 1, but which is simply just 4. So yeah, let me just recall it. RP gamma minus 1 over gamma. Now let's read again. They say the blades are gradually inclined and the slip factor is, I don't know how do you guys call slip factor, but in this our case here, let me just call it S. They said guide vans, they are saying guide vans at inlet air angle. Remember, if you look at the drawing here on the explanation, these things, they come at an angle. There is an angle here. There is a triangle, so there is an angle there. So they're saying that it comes at an angle. Let's call this angle theta to be 20 degrees. Now they say take the mean diameter of the impeller eye. The impeller eye, it is simply the one that is subjected, like at the entrance, if I can call it like that, is 200. So what is that diameter? It is the diameter here. That D is what? 200 millimeter. Now what is happening? We have the absolute velocity at inlet. What is the absolute velocity at inlet, guys? It is simply CAI. It is this velocity. The velocity that they call CAI, it is the absolute velocity at inlet. CAI. So whenever you hear inlet, it is CAI. What is CAI? CAI is 150.
120.
120 m second. Now, what is the question? The question is calculate the diameter of the chip of the impeller chip. What is it again? The diameter of the impeller of the impeller chip. You have to make the difference. That diameter comes from the formula of CBE. What is CBE? CBE, again, it is also pi multiplied by d multiplied by n over 60. But in this case, my good people, what is our d? We do not have it, which is what we are looking for, this guy. So I'm gonna repeat myself. CBI, you use it, the velocity that you use, the diameter that you use is the one that is written impeller eyes. If you hear the impeller chip diameter, it is the diameter created by CBE. Let me show you again in another example in the textbook. In this example of the textbook, they said here the chip diameter. What is the chip diameter? It goes with what? CBE. That's why you see they use that 590 here. So you can recall it like that. Any question, guys?
Let's move.
Okay, we move. Yeah, let's move. Time. Hey, darling, something about you. Okay, whenever you are solving this problem on the compressor, no matter if you don't know what is being asked, first thing to do is solve for the power.
Sure.
Because this power would be the one. Remember, power is also equal to what? If you remember the formula that I wrote, it is equal to M multiplied by what? From the textbook, it is CBE multiplied by C, they call it CWE. CWE minus CBI multiplied by CWI. Now, remember, my good people, we have already solved for the power. What is next to do? The next things to do, it is simply to solve for all the elements that are inside here. We have the power. You have the power which is here. Do you see it, my guys? Now, you also have another formula that says that on the textbook. It says slip factor is equal to C prime WE over CWE. Now we've got everything. Which one can we... Yes?
Can you please just repeat.
Oh, why should I repeat, my brother?
From the power then.
Oh, from the power. This formula, I just copied it from the textbook.
Oh.
Do you see this one?
Oh, okay. My network is not networking, ne?
Nah, buy data, my G. Buy 1 gigabyte data, you can watch this class properly. Or you only want to buy for the Rato, you don't want to buy for yourself. Okay. Yeah, I just copied that formula, my brother.
Yeah, it's fine,
I didn't do anything. You also know that S, which is the factor, it is C prime WE over CWE. Okay, guys, can we proceed now? Let's start by solving. Let's get CBI and CWI. I think this one we can get it easy, right? How can we get CBI? For CBI, remember, we've got everything. We just need to apply the formula. Okay, let's do that. Let's get CBI. Ooh, that's a wrong handwriting. I need to buy a pen, and a digital tablet for my online. Pi is pi. What is D? I said D is the diameter given here. The impeller I. 200.
We're using it.
You saying?
We're using it in meters.
Yes. In meter is what? 0,2.
0,2.
Yes. What is N here?
16,000.
Tanko means
No.
thank you. 60. If you do this, you're gonna get CBI. What is the answer?
Um, 167,55.
167,55, and they are keeping it in meter per second. Okay, guys, we got CBE. We can also get CWI. CWI is simply CAI, sine theta. Remember the theta that I called there 20. What is CAI in our case? It is 120 sine of 20. If you do that, my leader, you got CAI. How do they get it again? If you look on the example on the note, do you see what is CAI, my brother? It is just on the opposite side. Do you see CAI here?
Mm-hmm.
Yeah, when you look at it as a right angle triangle, CW here. Here it is 0, but it changes depending on the angle of the pre-wheel. I don't know if you see.
Mm-hmm.
If the pre-wheel is 20 or what, this thing keeps moving. It keeps moving. So how do you get CAI? Remember, do you see where there is CWI?
Mm.
Look at the right angle triangle. It is on the opposite side.
Mm-hmm.
It was the simple reason that CI is this sine theta, sine this angle here. Let me do this so that we can all be on the same page. Angle of the pre-wheel. Who's joining at this time? You always coming late. Even online you are late. Mr. Gordon, even online you are late, my brother. Okay, do you see what I'm talking about? This thing is changing according to the angle of the pre-wheel. Do you guys agree? The angle of the pre-wheel in this our case, it is this angle. It is 20. Do you see what I'm doing, guys? So this is 20, but this one here, it creates a right angle triangle. So what is CW? CW here is on the opposite. That's why you see CWI is simply CAI, sine of the angle of the pre-wheel, which are called theta. All you have to do for CWI, you can simply remember this. As long as you hear that there's a pre-wheel angle, you know that CWI is this sine this. But this is how it is proven. Are you with me, my guys? You see, only one speaking. How about the other one? Are you with me?
Yeah.
Yes. Can I delete this picture? Let me leave it there. So if you calculate this, what is CWI?
41,04.
It is 1,04.
41,04.
Is it also raining there by you?
No.
Yes.
No.
Okay. Then we are not in December.
Yeah.
We are not in December. Okay, guys, we got CWI and CBI. What is next? What can we get next? Do you guys agree that for us to apply this formula, if we have the S is the factor, right?
Yeah, we can get SWE.
We can get CWE. We can get CW prime E, but before getting that, we can get CWE. How do we get CWE, guys? Let's get CBE. What is CBE, guys?
Pi D.
It is also pi D N over what? 60.
60.
But in this case, D is our unknown. That's why here we are simply going to have, what are we going to have?
Pi 1.
Pi multiplied by 16, right? Divide by 60 D. D is our unknown, what we are looking for. So Kibukai answer. Angle of the pre-weir. Oh.
837,76.
837,
76.
76 D, without forgetting D. Now, how do we get this guy CWE now? Remember, because this thing is radially, let's read the problem. Is it radially inclined? They say the blades are radially inclined. The term radially here, it is simply being explained in the textbook, like if you do have radially blade or radially inclined, it simply means the value of your CW will be the same as the one of your CBE. When do you have a radially inclined? Let me show you an example. Do you look at this drawing A? Look at where my this thing is showing. On A, in this case, I don't know if I can zoom in. Do you see CWE? When it is radially inclined, you have CWE to be equal to CBE. That's what it means. The figure can change depending on what's happening here, but that is what it means. So that's one of the reasons, even on the example here, they do consider CBE to be equal simply to CWE because our system is being radially inclined. So what does it mean in our case? What are we going to do here? The same value of this guy here will be the same also for this guy. Any question, guys? Any question? I'm gonna repeat again.
Mr. Eyes, can you please repeat the CW what?
Which CW, my brother?
The one you just wrote right now.
Oh, I was saying, as long as you hear that in your question here, these things are being radially inclined, or there is a radial being involved here in this expression, it simply means your CWE, your CBE, let me write it here, your CBE will be equal to your CWE. So because we solve already CWE on top here, the answer that we got will be equal to this one.
Right.
Do you see it, my G?
Yeah.
Mr.
So if there was no radially inclined,
Your call ends in 15 minutes.
Yeah, ne?
say how would we find out if there was no radially inclined?
No, because it's stated.
If it was not stated, how will we? Is there a way of finding it?
Then if it is not stated, it means they should give you another information. It's either that information should maybe be they tell you what is the angle of beta E, something that can help you to get it. But don't worry, you will not have such a case tomorrow. But if I have to explain it to you, if it is not radical what, it means there should be an extra information. Either
Okay.
they'll give you this angle. Do you see it, my brother?
Huh?
Wrong.
Can you hear me, my brother?
Yes.
Hey, my brother, do you stay with your wife, man? Hey, you guys are living the life. Yes. Did I answer you, my leader?
Yes.
Yeah, don't be shy that because we heard your wife there, my brother. She's there, Maji. Hey, now you are shy. Anyway, nevertheless.
Man. Hey, eyes, man. Hey, shy, man.
Oh, was it you or it was Esma?
It's not me. It's not me.
You see, you talk. Some people are applying. Now, okay, Maji. I was saying, if there is no information about radial what, they should give you either an angle like the one that was here. They said it was 20. They should give you an information that can help you to get this. But in that case, don't worry, you will not have something like that tomorrow, even on the exam, because yeah, I don't want to say if my videos are recorded. You say? Okay, let's finish this question, guys. We have 10 minutes to finish this. Do you guys agree that if we found CWE, can we find C prime WE?
Yeah.
Because S is equal to C prime WE over CWE. So therefore, C prime WE would be equal to S multiplied by CWE. So what is S? S is how do they call it again? They called S to be a slip factor. It's 0.85. So we do have 0.85 multiplied by 837.76D. Now we can leave it like this. Now, my good people, what we are looking for is what? We are looking for this diameter. The only relation that can help us to get it, it is the power formula. Let me recall it again. In this formula, do we have any information about the flow rate? So if the flow rate is not mentioned, so it means in our formula, we don't have to use it. Only if it is mentioned. So what is power? We know that power is CBE CW prime E minus CBI multiplied by CWI. Now you have everything, my guys. What is your power? Your power is the one that you also got from the temperatures, which is 172.74. Okay, what is CBE? You guys found that CBE is 837.76. What is C prime W? So it's gonna be multiplied by, remember there is a D here, né?
This is CBI and C.
Yes.
CBI.
This one is
CRI.
It is CRI.
Yeah, your handwriting, I don't know.
Okay, no, it is CWI.
Oh, it's CWI.
You. But you are speaking, nobody is speaking at the back. Are you alone?
Yes, I'm alone.
But it's raining. Okay.
So,
Yes, none of the less. Okay, this is CBE. What is CW prime? It's raining, Sissy. It's bad to be alone. It's raining.
I was born alone.
You are scared of Bujolowanisa.
I was born alone.
Jolo is nice, guys. Okay, minus. What is CBI? If you remember, we solved CBI from the beginning. 16755.
CBE.
Yeah, we all were born alone, but you can't be alone. Times. What is CWI? CWI is this guy that you found here. 41,04. Because it is wrong to be alone.
It's electricity. Yeah.
Now, guys, now we can do the math here. This D times this D will become square. This and this will become square. So what you will be having is you'll be having 837,76 everything square multiplied by what? D square. Multiplied by 0,85 minus.
Rainbow.
Yes, I'm listening.
I get the D squared. Is it not that 837,76?
Remember, each
It's squared.
83,76
Okay.
they have a D. This one has a D, this has a D.
Okay, squared is fine. Continue.
I'm continuing.
1, 6, 7, 5 times 41, 4.
Even when I cry, it doesn't mean I am weakening. Oh, it's gonna be called tomorrow. Yo. Okay. Now, guys, now I cannot do whatever. This is the math now. If you want to make this subject of the formula, what is this? Can you help me quickly?
Yeah, I'm on it.
Can you do this time this when you bring it here is going to be positive. So we'll have 172,74 plus. What is this answer? This times this.
Sure. The answer that we must get what?
We are looking for D.
We must get the D there.
This D, the diameter that you are looking for.
Sure. Okay.
Guys, we have left with how many minutes? 6 minutes. Let's do it in 6 minutes, please. Daphne, you're so quiet. God then so more. Hey, Mr. Isam, can you talk to me, my brother?
Yes.
Yeah?
Wait, no, open the mic. I want to hear. She's gone, my brother.
Who?
Mr. Isam.
Oh.
Is she gone or is she still there? Hey, my brother doesn't want to open the mic. Yeah. Tomorrow in class.
So the one who's guilty is the one that is laughing there.
Yeah?
The guilty one is the one that is laughing.
Me, I didn't catch him. I caught you.
So, When did we get the power?
Remember, the power I said, the step is easy. We get that power using the temperature. This step here.
Let me see.
First of all, you have this one.
Okay.
You get T2S. You make T2 minus T1 substitute the formula. You bring it under this one here. You get the power. The same power.
Are you recording this?
Yeah, it's being recorded. I will upload it after the class automatically.
Oh, is it gonna upload it on YouTube, no?
My YouTube channel. Just know, my brother.
Oh, no problem.
My G, your girlfriend voice is inside this video. And me, I don't do editing. I just post what's here.
No problem. I don't know who you're talking about, but it's fine.
You are happy, ne? Guys, what's the answer? Can you make d square subject of the formula? Guys, let's do this, man. We don't have to waste time here, please. I'm getting hungry. I'm thinking of walking to KFC and eat. But it's cold.
There is a possibility. Sometimes.
What do you get, Bukala?
I'm still calculating.
Hey, so I'm getting 0,1087. Or maybe I'm making a mistake there.
For what?
Final answer.
Final answer is what?
0,1087. Or maybe I'm making a mistake.
0,1087. This is not what they are getting then. Them they are getting, what we're supposed to get is, what's the answer? We are supposed to get, Kibukai, that answer. 549, so you're supposed to get something like 0,549.
59656.
Let's see where did the mistake went. Let me check maybe the solution that you sent in the group. Okay, on the group I see what was your power?
Yeah, I also get the same answer.
Inside the group they get the power to be 172, which you got. Hey, I made a big fuck up, my brother.
Okay.
The big fuck up is this thing here is kilo. The unit of the power here is kilojoule.
So I must times it.
You have to 10 to the 3. Can you try what's the answer now? Guys, it is already 6 p.m. Let's do the other one because I want to rest, have another meeting. Even though I cry, it doesn't mean that I'm weakening.
Yeah, it gives us 549.
Yes. Okay, you see the mistake now? The answer here is in kilo. The power here is in kilojoule. Is it kilojoule something? Why? Because this thing here, the CPA is in kilo. That's why it's giving the power to be in kilojoule. So remember to make it 10 to the 3, you're gonna get that answer. Are we good, my guys? Let me close this link and send a new link for 11.4. Hey, my G. You should have
What's
left
up?
there. I wanted to see you. You closed there. Let me open mine as well.
You want to see me?
At least we can see each other.
Are you going to upload that video?
Just after, yeah.
Yeah, please, man.
Just after this question here.
Which question are we doing now?
11.4.
Oh, we didn't do 11.14. That's not 11.14.
It was 11.4. Hello, Daphne. Can I see you too? Kikateti. Okay, let's do it fast. Bukale.
Yes, sir. Mr. Ice,
Yes, can you hear me?
you're doing 11.4 or 11.14?
It's 11.4.
11.4.
What is 11.14 again? Let me check.
It's 11.14.
Hey, 11.14. Ish, guys. My brain is working overtime this day. I'm barely sleeping lately.
But, okay. But we did 11.14, Musi.
Yeah, well, you and I, but Mr. Marouane and Bukhale, they were not here.
Let me go cook then. I'll watch
My
the other
G,
video.
let him cook. Let him cook. Enjoy. We should let him cook.
Yes. Sort of future.
Off there.
You see, Mr. Wa, now I can also hear your girlfriend voice. And Mr. Moran. Hey, you guys are living the life, my G. It's raining and you are in couples. I wish I were you. My brother. It's raining, but you are 2 by 2. I think mechanical engineers are living soft life, ne? Other courses, people are singers. What is happening now? Yes, let's do it quickly, eh? Because Kikrateti. Print. Let him cook. Okay, at a particular stage of the axial flow compressor, you can see when you are reading which type are you, ne? What do you need to know on the axial compressor? Let's call up the book. Let's see. Bukale.
Yes, you love my name, ne?
No,
I'll give it to you.
it reminds me. I don't know what's the show. I think I watched that show with.
And you're calling it wrong.
It is what?
Come in.
Huh? Hey, Uban, respectable. Why am I swiping? Let me check my textbook. I'm just swiping. I have a textbook here. It is axial compressor flow. It is page 361, 360 on mine. Okay, this is the diagram of actual compressor flow. Let me just print it. I was even thinking of drawing it, but let's print it. It is here. Whenever, my good people, you hear axial flow compressor, what am I saying? This is the graph that you refer to. Now, here we go. They said at a particular stage of the axial flow compressor required temperature, this is the temperature, T, which is 20K. The blade mean velocity is the one that they call CB, this one. Velocity of the blade. Key 200 meter per second. Who's texting here? Who is texting me? I don't want text, I need cash. Okay, the flow velocity, this is very important here. I need to explain this. The flow velocity is the one that they call VF. It is equal to 150 meter per second. They say the degree of reaction is 50% of the mean radius. Okay, 50% of the mean radius. I don't know what they mean by that. But we have a work factor. Work factor of 0.9. Your book is calling the work factor to be to y. Now remember, this one here, the diagram that you see here, it is called velocity diagram. Normally, for you to draw this, you need to convert your whatever dimension that you have in meter per second. You need to create a scale, and then you can plot this. Do you know why I'm saying that, my brother? Can you plot 200 meter per second? Can you plot it, my brother? Can you draw it? You know you can draw 200 meter. You can draw 2 meter, but you cannot draw 200 meter per second. So you have to create a scale. You can say 200 milliliter per second corresponding maybe to 20 millimeter. So it means when you come here, you have to do 20. And everything that you will do will be referred to this scale. But in this thing you're not drawing. You guys used to draw it in earlier stage, which is I think thermodynamic 3. You guys were drawing unless you didn't do it. Actually, it's bad. You see, this feeling I'm not keeping. I'm not catching. Okay, guys, there's something that I wanted to explain. Let me use my ruler. Let me use the technology. 90. Do you guys see this axis here? In fact, I was not the first guy. I was the second, I think the first in mechanical engineering to do online classes.
Banana. Banana.
What is that? It's ice education. Ice education is the future. It's the present and the future. We've got the tools here. Okay, what is next? Hey, wait, now move. Okay, do you see this distance here, guys?
Yeah.
It is simply this axis that I draw here. That distance, it is called VF, velocity flow. It is the same also here. Please text me on LinkedIn. Okay, here we go, guys. What do we do in this case here? First thing to do, we need to know that work factor is equal to actual work over how do we call this thing again? How do you call DCW again? It is actual work. What is it called again, guys? I'm forgetting the name. Okay, but your actual work, it is simply CP over change in chi multiplied divided by CB.
The Y stands for what?
Why it is called work done factor, this thing. I just wrote Y because this is how your book is calling it. Where is that formula? Your book is saying that work done factor is actual power work over this. They call it Y. Do you see where it's come from?
Okay.
I'm just copying that. So it is CB. Let me check again the formula. Let me just copy. CB DCW. Okay, this is what's happening. Now,
Hey, Mr. Eyes,
yes, my leader.
there by 150 meters per second, is it YF or what?
VF,
Oh, VF.
velocity flow.
Oh,
There's no
okay.
YF here. Okay, it looks like Y, ne?
Yeah.
I don't know how to write. Let me write it properly.
Yeah. Hey.
Yeah, it's very wrong.
Nice. Hey. Felicia, what's that last thing when?
Well, man.
That time of the month.
It's that time of the month.
Which one? Ish, what are you guys talking about? I don't even know. Hey, my problem is I want to be involved in everything. Some other things doesn't concern me. I'm supposed to be giving a class and then eat. Ish, my G is cooking. Hey, my boy, I don't remember.
What did you do in the morning?
We did strength.
Applied. Only.
Yeah, and we did chapter 15 on this one, and I promised to do this one online.
You finished 15.2.
We did.
It's similar to 15.1.
No, not similar, but you need 15.1 to solve 15.2.
Felicia, I will send you the solution.
Okay.
Hey, SolidWorks is a nice tool, yo. Okay, no problem, guys. We have actual work. What do we do here? What do we solve here? What are we even solving? We are looking for what? We are looking for calculate the required blade angle and at min radius. Okay, here's another thing that you need to know. When you have an axial compressor, do you see that this angle here and this one are the same? They are the same size, they are symmetric. It simply means if you get alpha I, you get beta E. If you get
not I.
No. This is alpha I, this is beta E.
Oh, okay.
If you get alpha E, you get what? Beta I.
Beta I.
Yeah, so the question that is asked here, it is simply to calculate the required blade angle. It is to solve for these angles. So how do we solve it? My good people? We can solve it. Do you guys agree that?
We are solving for what? We are solving for what? BI, ne?
No, blade angles. We are solving for BI. We are solving for all these angles.
Oh,
for all the four, but remember, if you find one, you find the other one. So you're only solving for two angles. Do you see it, Felicia? Now, my G, what's happening here is simply some math, Niana. Do you agree that if I get DCW, I can get this angle? You can play with geometry. Do you agree, my brother?
If you get the C?
If I get DCW, if I get this distance, I can solve for this angle. So that's why we are going here on this factor here to solve for DCW. That's the only reason. Now let me finish this. I want to finish this in the next 20 minutes. My time is precious. My time is precious, like precious. Loving you is a losing game. Okay. So the aim here is to solve for DCW. Do you agree that what is DCW? It's going to be CP, change in temperature, everything divided by what? CB times Y. Do you see it? So what is CP? Remember, this thing is exposed to air. Everything that you see here. That's the reason that the CP that we use here is the one of air, which is 1,005 times. What is the temperature here? We don't have a change in temperature. We have a constant temperature. So we can only take 20. And temperature should be in Kelvin. It's already in Kelvin. No need to convert. So you have to pay attention. It is 20K. Now, what is next? CB is what? CB was given from the beginning, 200. And what is Y? Y is the factor, which is 0.9. So what is the answer of DCW?
Mr. Ice, is that the Y it's what? It's 0.9.
Yeah.
Why it's called it is called work done factor. It is what we are calling Y.
That's 0.112.
There's something that something I'm saying that I'm not sure. I'm not sure if we have to convert this CP here times 10 to the 3. Mr.
Yeah, I
Esper,
think so.
did we convert it? Last time we did it. Is it here? No, Maji, now I'm asking a serious question. It's not about your girl. Did we convert this, my bro? Mr. Isam?
Yes, we converted.
Yeah, we have to convert it. Maji, don't feel offended. I was just making a joke, not to...
No, sir, I'm not even a culprit, so don't worry.
I thought you took it maybe personal. Now, what is the answer? But it's not wrong, Maji. You're at varsity, you must enjoy.
Yeah.
That's part of the enjoyment. That's what parents don't tell you. The only thing they tell you is go to school and study. They should also say enjoy. Me, that's what I would tell my son.
Times 10 to the power
3. Answer Kibukai.
so phone up 3.
It's 111.67.
111.67. Ooh, Daphne. I missed you. Okay, guys, let's see what's happening. If we have DCW, do you guys agree? Now, can we solve for alpha I, guys? Look at this. What is this one? I don't want to mess up, but let me just do it like this.
What are the units?
It's meter per second. Remember, this thing is a velocity diagram. Everything here is in velocity. Do you see it, Sissy?
Yeah.
Let me rewind. Okay, look what is happening. If you look at this right angle triangle, let me try to be accurate. Okay, do you see that right angle triangle, né? That I just showed there. This one. Can we get alpha I, guys? Guys, this should be quick, né? It's a right angle triangle.
Yes, it's a right angle triangle then.
Can we get alpha I?
We got CW, ne?
CW is the distance from here to here.
So we can get.
Or if you want, can we start first by solving these distances? How do we solve it? Remember, everything here is CB. Do you guys agree? The length from here to here is CB. It is 200 meters per second. 200. Do you see it? Guys, please talk to me.
Yeah.
Okay. What do we have here? We have DCW, right? Now, if you take CB minus DCW divided by 2, it will give you these two dimensions. Because this thing, DCW, is actually acting in the middle here. Do you see it, my brother?
Yeah.
So if you take CB minus DCW divided by 2, it will give you these values.
Answer divided by 2.
No, not
44,
answer divided by 2. It is CB minus DCW.
Minus CW over 2.
What is the answer?
44,165.
So this one is 44,161.
165.
165. It is also the same here. 44,165. To know if you are getting the right answer, you can take DCW plus these 2 here. It has to give you 200. You can check. You can take DCW plus 41,65 plus 41,6. What to find here? It has to give you CB. It has to give you 200. Who's joining this late? Mr. Maputi Matebo. GP Mutaung.
Yeah, it gives us 200.
Yes. Now, what does it mean, guys? Now it's just met. There's no longer thermodynamic here. Remember, what did I say? What is this distance? VF, right? It is this distance of this and this. It is also of this and this. Now, if you want to solve for alpha I, what can you use? You have the opposite. You have the adjacent. What formula can you use? You use tan. If I have tan alpha I, what will it give me? What is the opposite? 44, 165. What is the adjacent? It is VF. What is VF? 150. Now, what is the angle alpha 1? I remember alpha 1 is equal to beta E. So what is that angle? Remember, the angle is tan inverse of this. What is that? Guys, please, let's try to finish early. Just want to rest a bit.
0.294.
The angle is 0.294.
Wait, that's not an angle.
Now, find the angle. It has to give 16,4 according to the textbook.
Yeah, 16.41.
It's just some math, guys. Degrees. Now, you can do the same also for this right triangle. Do you agree that, okay, now we have to think, guys. We have solved for alpha I and beta E. So we need alpha E. How can we solve for alpha E, guys? Do you also agree that this one is a right angle triangle? So you need to be able to see it. You don't have to claim it. You have to be able to see this figure. It is not accurate, but do you see this right angle triangle where the angle is alpha E? Now, what can we do to solve for alpha E? Remember, you have this distance here, which is the opposite. You still have VF. which is the axial. You can also go tan.
Mm.
Now, what is this distance? This distance will be 41,165 plus dCW.
Yeah.
Do you see it?
It needs to be 44,1
44,165
plus
plus dW, it is 11, what?
1167,
11,67.
which is 155,8.
Okay, I'm just writing it all. Everything over 150. So if you do that, you're going to solve for alpha E, which is equal to beta I, which should give you the answer as well. Could have made 2 different videos, ne? This one, but it's fine. How long is this recording? Don't tell me that. Okay, it's an hour and 21 minutes. Not bad.
This is the last question, you know?
Yes, Madina.
Yeah?
Yeah, I'm listening to.
Is it the last question?
Yeah, bro.
Aye, good.
That's
Let me.
46,1.
Hey. Yes, Mr. Aaron. How's it, my brother? Hey, my bro. No, sorry, bro. I had online classes to cover with my student, but that's why I didn't come. But I'll look at it tonight. Tomorrow we're definitely meeting. Je te rappelle, bro. Je te rappelle. Yes, my guys. Easy. Have a busy night. Thank you. Where do I close the recording? Let me close the recording.
Yeah, please upload.